Hello students, welcome to Code with Vinay. Council has released a new specimen question paper for ISC 2021 Computer Science Paper 2, that is Computer Practical. There are two changes which I have noticed in the specimen paper. Number one, there are changes on how the paper will be conducted, and that is primarily due to the COVID protocols. And number two, there's a slight change in the format of the paper as well. Now let's have a look at the paper. This year, the computer practical will take place over 2 days. Day 1 will be the planning session for 90 minutes and day 2 will be the examination session for 90 minutes. Now notice, on day 1 you are supposed to write the algorithm and the program, and thereafter you will hand over the answer scripts along with the question paper to the supervising examiner, and when you will come back on the day 2, then you will code, type, test the program on the system. All the written work has to be completed on day 1, and you will not be allowed to carry any stationery items as well as pen, pencil, paper, eraser on the day 2. The second change in the specimen question paper for 2021 are the questions themselves. Notice, question number 1 is for finding the day after n days. That is okay. Question number 2, which was usually based on double dimension array, has now been replaced in the specimen paper by a question on strings, and question number 3 is a question which is actually based on number theory. Now, another point to be noticed is that question number 1 and question number 2, that is the day after n days problem and the string sorting method, is basically the same question which was asked in 2009. Question number 1 and question number 2 of 2009. However, question number 3 is actually a new question on Mobius function. I've already made a video on question number 1 as well as question number 2, and if you are interested, you may find the link in the description below. So now let us solve the question number 3, which happens to be the only new question of the specimen paper of ISC Computer Science 2021. Let's have a look at the question. The question says, a Mobius function m of n returns the value -1 or 0 or 1 for a natural number n by the following conditions are defined. The conditions are: the Mobius function returns 1 when n is equal to 1. It returns 0 if the prime factor is contained more than once. Like for example, if you see the example which is given below, 78 is 2 into 3 into 13. So all the prime factors are distinct. So in this case, what we have to do, we have to find -1 raised to the power p, where p is the number of distinct prime factors. However, if the prime factors are not distinct, like for example in case of 12, the prime factors are 2 into 2 into 3. So 2 is duplicate. So in that case, the Mobius function will return 0. Now let us have a look at the input and the output. The input is a single number which is to be entered by the user on the same line as the message input, and then output is consisting of 3 lines. First line is the prime factorization, second line is number of distinct prime factors. If there are no distinct prime factors, then we'll say duplicate prime factors, and please note 1 is a special case, and in case of 1 we'll say no prime factors, and also instead of prime factorization we'll simply write 1 is equal to 1, and the last line of output will contain the value returned by the Mobius function, that is either 0 or 1 or -1. So let's begin with the coding part. I've already made a boilerplate code so that we can speed up things a little bit. So I have a scanner object ready, but before we can enter the value, we have to prompt the user for the input. So we'll say system.out.print, and then we'll say input/t, and this will be followed by entering the number, which in the question paper is given as n. So we'll say int n is equal to in dot next int. Now this will accept the integer. Once this is done, now I always prefer making a proper object oriented program, so we'll do the same thing over here. So what I will do is I'll create a class which I'll call as Mobius, and then I'll create an object of Mobius, and then I'll create an object by saying Mobius obj is equal to new Mobius, and I'll pass the number n. Once that is done, I'll say system.out.println, and then what I'll do, I'll simply say print obj. Now I'm trying to print an object rather than a string. So in these kind of cases, what happens is that computer tries to convert this obj into a string, and in order to do that, it looks for a function by the name of toString in the class. If that function is present, that function is called. So all our printing logic will go inside the function toString. So let's begin with the actual code. So we'll say class Mobius. Now within the Mobius, we need the instance variables. So we'll declare them one by one. So first is private int, the number itself, that is n. We have to find the product, so we'll take one more variable by the name of product. Other than that, we'll create the variables as and when we required. So this is done. Now in order to initialize, we'll require a constructor. So constructor is a function having the same name as that of the object that will accept the number n. Now since the name of the local variable n, that is this n, and the instance variable is same, I'll say this dot n, and in this case this dot n refers to the instance variable, that is the n over here, and we'll say that okay, this dot n is equal to n. So this will initialize our n. Now since we have to find the product, we'll say that okay, product is equal to 1 initially, and we'll keep on multiplying it by -1 as many times as required. So this is one thing. Now once this is done, we want to do the prime factorization. So for that, what we'll do is we'll create a function which we will automatically trigger from the constructor itself. So I'll say prime factorization. So this method will be called as soon as the object is initialized. Now let's create the function. So public void prime factorization. Okay, so now we have to do prime factorization. The first prime number is 2, and then we have 3, 5, and so on. So in order to make an efficient program, what we'll do is we'll first keep repeatedly divide by 2. Once that is done, we'll repeatedly divide by 3, and then we'll straight away jump to 5, then 7, and so on. Okay, so it's not a good idea to destroy the original number n, so we'll first make a copy of it, and for that I'll say that okay, there's another instance variable called temp, and here I'll say that okay, let's make a copy. Temp is equal to n. So this will make the copy of n. Once that is done, we also have to take care of whether or not a duplicate is found. So for that, we need another Boolean variable to keep track of the duplicates. So we'll say private, because we have to keep track, true or false sort of thing. So we'll say Boolean, and let's call it duplicate found. So that's another variable. Once that is done, what else we require? We require to count the number of factors. So we'll take one more variable, factor count, plus in order, we have also to declare a temp we have already declared. So that's not an issue. So now we come over here. Initially, we'll say that duplicate found is equal to false, because we haven't divided, so there are no divisors, so there's no question of duplicates at this point of time. So initial value of duplicate found is equal to false. Now once that is done, we'll also say that okay, factor count is equal to 0, and we also have to store the prime factorization, and that will require a string. So one more variable required, and that is private string, and what to call it? Let's call it prime factors, because that is what it is storing, prime factors. And then we have to initialize that also. So we'll say that okay, prime factors equal to, what was actually the format, prime factors equal to, we have to first give the number followed by an equal and followed by the actual prime factors. So let's begin. We'll say prime factors is equal to n. That will be followed by a space equal to space, and then we'll add the prime factors later on. Now what we have to do is, since we are going to divide by 2 first, then after that is done, so let's say int divisor is equal to 2, that is our first divisor, and later on when we'll take the loop will go till the half, and I don't want to calculate half again and again, so what I'll do is I'll say half is equal to n by 2. So that is also done. Now we have to factorize twice, once for 2 separately and once for other prime factors, that is 3, 5, 7, etc. So rather than doing having the same loop at 2 places, we'll make a function which will actually do the factorization. So we'll call the function as factorize, and I'll pass the divisor. So let's proceed with the factorize function. So we'll say public void factorize, and we'll get the divisor as an argument. And then this is going to be a simple and straightforward function where we'll keep on dividing by the divisor till it divides. So we'll say that, okay, while temp modulus divisor equal to 0, that is till we don't get a 0, we'll keep on dividing, and within the divisor we'll say that, okay, prime factors plus is equal to, and we'll say that, okay, divisor plus, and then we'll add an equal to. Let me check what was the into sign. Okay, for into they were using small x, so we'll also do the same. Earlier I was thinking that I'll have an asterisk over there, but since the question is saying x, we'll use a x. So divisor plus x, this is done. So this will actually store the final output, and then every time we'll say that, okay, temp divided by is equal to divisor. So this will divide. Once that divisor is done, what else? We have to count the number of factors also. So we'll say that, okay, int current factor count is equal to 0. Initially, how many times we have divided by the current divisor, that is 2, 3, 5 or 7. We'll store it in the current factor count, and as soon as it's divide, we'll say that, okay, current factor count plus plus. So this will increment each time we divide, and we'll also have to make the total factor count as well. So we'll say factor count plus, no, hold on, yes, factor count plus plus, and then we'll have to find the product as well. Product into equal to -1. Please note, you might consider using, like for example, if you go over here, -1 raised to the power. We can use math.pow at the end, but please understand math.pow is quite expensive because it works on double. Here ours is a very simple case. We need to multiply -1 into -1 a certain number of times. So instead of having math.pow, what I'll use is I'll keep on multiplying it within the loop itself. So once this is done, we have divided the number as many times it divides, will come out, and now we have to see whether the duplicate is there or not. So if duplicate, and we have to do it only once, because if there is a duplicate, there is a duplicate. So we'll first check that if duplicate found is equal to false, only then we'll try to make it true, otherwise we will not touch it. So once it becomes true, it will remain true. So we'll say that, okay, duplicate found is equal to, and we'll say that, okay, current factor count is more than 1. So please note, current factor count more than 1 is actually a Boolean expression which will evaluate to true or false. And if current factor count is more than 1, or obviously it will become true, and therefore we can assume that, okay, the duplicate has been found, because the number of times the n has been divided is actually more than 1. So this does the factorization. So let's proceed with the factorization. So first time we'll call the factorize method with the value 2. That means the number will be divided by 2 as many times as required. If the number of time it gets divided by 2 is more than 1, we'll say that the duplicate has been found. Otherwise, we'll proceed. Once we come over here, we'll divide by the remaining divisors, and I'll say that, okay, divisor equal to 3, that is the next odd prime number. Obviously, all prime numbers other than 2 are actually odd. So we'll start from 3, we'll go on till the half, that is less than equal to half, because we have already divided by 2. It cannot go more than half. And then we'll increment in steps of 2, because there is no point in dividing by 4, 6, 8 or other even numbers, because we have already divided it by 2 in the beginning itself. So we'll say that divisor plus is equal to 2, and every time we'll again factorize ORIZE by the divisor, and the divisor will keep on changing from 3 till the half in steps of 2. So once all this is done, our factorization is complete. Our answer, that is the prime factor, is stored over here. So this takes care of most of the things. Now we actually have to calculate the Mobius value. So let's do it. We'll say public int get Mobius, and before we actually do it, let's have a look at it once more. So if it is equal to 1, we'll have to return 1. If it is duplicate, then we have to return 0. Otherwise, we'll return the product, which we have already found. So let's do it. So the first thing is that if n equal to 1, we'll straight away return 1. And then if duplicate is found, we already have a duplicate found variable. If duplicate is found, then we'll say return 0. And if we are reaching the last line, then we'll simply say return product, which has already been multiplied by -1, the required number of times in the factorize function. That is, where is it? Over here. Now, what's left? Okay, now we have to print it. So we are directly saying system.out.println obj. So that means if we create a function by the name of toString which returns a string, computer will automatically call it. Now here the most of the work will be done. So let's see. Let's see means let's see what we were doing over here. So the first thing which we have to do is we have to display output. Okay, then output we have not displayed. Okay, first we'll say output, then 78 equal to prime factors. Okay, let's do it. So we come over here. In order to store the output, I have to create another variable called output. So I'll say string output is equal to, and output will consist of, there is a tab in the beginning, and after the tab we'll say prime factors, and prime factors plus, we'll have to again change the line, and the next line is shifted by 1 tab, so a /t. I'm talking about this tab in the beginning. Okay, so this is done. Okay, one more point is that we are adding into equal to, which means that there will be an extra into sign at the end. Notice we are saying we are adding this at the end of the string, so this is actually extra. So this we have to get rid of. So that we'll do over here. Before we begin, we'll say that, okay, prime factors is equal to prime factors dot substring. We'll start from 0 and we'll stop at 2 places before the final position. That is, we'll say that, okay, prime factors dot length -2. So this will remove the last 2 characters. Then what we have to do is, okay, 1 is a special case, so first we'll handle 1. We'll say that, okay, if n equal to 1, we'll say that, okay, output plus is equal to first a tab, then we'll say 1 equal to 1 directly, then a new line, and then after the new line we'll have a slash t, and then hold on, let me check again. In case of 1 over here, and then we are saying no prime factors. Okay, so after that is done, after the slash t, we'll say no prime factors. So this is done. Oh, there should be only 2 equal to over here instead of, right, 3. This is done. Now the second case is if there is a duplicate found. So we'll say that, okay, if the duplicate is found, then the answer will be different. We'll say that, okay, output plus is equal to, and the message was, I'll just copy paste the message from there to save some time. We'll say duplicate prime factors. I'll copy this from here and let's paste it over here. So the message is duplicate prime factors, and in the final else we'll say output plus is equal to, again in order to save some time we'll copy paste, and the message over here is number of prime factors equal to. So I'll copy this entire message from here and then I'll paste it over here, and obviously I have to display the actual factor count which is stored in the variable factor count. So the factor counts gets printed, and when everything is done we have to say Mobius of that number, that is m of n equal to whatever the case may be. So once we get out of this we'll say that, okay, output plus is equal to, the output has to go in the next line and it is slightly shifted, so we'll say slash t, and then we'll display the output as it is. So m parenthesis plus n parenthesis closed equal to plus, and we'll call our function get Mobius to get the value. Now let me have a look at it. This seems to be working. The only thing left is that we have to return the final output. So we'll say return output. Okay, so let's have a look at it once from the beginning. The initial value of output is where? String output equal to nothing is over here. Okay, so this is also done. So I believe that the program should work now. Let's check it. So the first value, where is the value, is 78. 2 into 3 into 13. Number of distinct prime factors 3, and Mobius function is -1. So let's run it. We'll run it, and when asked for the input I'll say 78. I press enter. So 2 into 3 into 13, number of distinct prime factors 3, m of 78 equal to -1. So it's working in the first case. The second case is 34. The answer is 2 into 17, number of distinct prime factors 2, and the Mobius function is returning 1. So let's try 34 also. So we'll run it once more and let's see 34. Okay, this is also working, and then there's one more case 12, and in this case we have to say duplicate prime factors and Mobius function should return 0. So let's try 12. I again run the program, and this time I'll say 12, and the program is working for this case also. And the last case is 1, and which will definitely work because we already have a separate if for this. So we go over here and we run the program for the last value, which is 1. We press enter, and the tab is wrong, so we'll just quickly correct the tab. Where is it? 1 equal to 1. So there is an extra slash t over here which I'll get rid of. So if I run it again, so I'll enter 1 once more, and there is still an extra line coming over here which we have to get rid of. Let me check. So what is happening over here is if n is equal to 1, this, otherwise also the variable is storing the value. So what we can do now is, if n is equal to, okay, we'll just remove that output plus and it will be overwritten. So now let's run it once more, and now if I enter 1, Okay, the answer is right, but this /t has gone now. So what we have to do, we have to get back this /t. So run. And this is hopefully the final time we are running it, 1, and there we are. So this is how the program will function. If you want to try out the code on your own, I'll be sharing it on the GitHub and the link will be shared in the description below. So I hope this video was helpful for you. Thank you.